So this is PN4036 week 10 lab. It is a video breakdown of the PowerPoint and resource that I would use for the question given to us in a class. So my introduction and key principles and things like that. So first of all, introducing the question and how I would ask the students to approach it. I would like the lesson to begin with me bringing in a model of a square-based prism and an oblique truncated cone, shown here on the slide. I'd put them two models together and I'd ask the students for just a 5-minute freehand sketch of what they think both of the cut solids would look like if we removed out the cut sections that they're in contact with. I'm expecting a very mixed bag of results. I'm not expecting perfection by any means, so I just want them to get visualizing initially because I think it's worth something. But obviously they won't get the correct solution or anything like that. In terms of approaching the question, I'm going to ask them the questions of drawing the plan, what do they think we need? I'm going to get their suggestions. Some of them will be wrong, some of them will be right, but I can filter through that as I go through it. This still will only take about maybe 10-15 minutes. So what do we need for the plan? I'm hoping that I get that out of one of the students, one or two of them. Finding the lines of intersection for the cut surfaces. They might be familiar with that, they might not be, they might just blank completely, that's okay. Number 3, developing the cone. Hopefully they'll be familiar with that. And number 4, developing the square prism, so after they're being cut. So they might know how to do parts of both of the last activities, maybe not how to do them all together once they're being cut, but that's okay too. I just want to get them familiar with the processes they will be using when they attack the questions, and they won't be stuck then. So the first bit of the question is the plan view of the oblique and truncated cone. For that, I'm hoping that they'll be able to give me the answer. So we know that the cone is oblique, and the elevation, the end view are given to us. So basically, once we have them drafted, we can draft them handy enough, just not the intersection curves. We can draft everything else. The yellow solid here, that's given to us, so I'm hoping that they'll tell me that they can go along the external generators and find the imaginary apex of the truncated cone. They can bring that down to the plan then and sketch in what we need. So we need drafting what we need. We can draft the elliptical base because we know the dimensions of the base. We can draft the square base prism because we know the measurements of that as well. So we can do that, we just can't do the cut surfaces as they're shown. So moving on then, we've our plan drawn. Developing the cone, I take the class onto that then. So they should be familiar with some of the principles here. I'm hoping that they'll know what this looks like. They will have done it before. In terms of just looking at just taking the points from the apex with our compass down to where it's being cut. In this one, it's just a plane, so it's straight, and then taking it over to the developments with the cone being divided up in 12 in the plan. Bring generators up, find the points, and they can pretty much plot that themselves. They should be able to do that activity independently, but I'm well able to take them through it. I hope that it won't take too much time, but they should be able to get it themselves. So they'll be familiar with those principles. Moving on then, just developing the solids after they're being cut. So basically, we can draw our end view. You can see that there. Then the curves, which will have had to be drawn in before we develop. So we can take our generators, which I discussed before, we have them drawn in, and the next thing that they will hopefully be familiar with, but it's not too bad I don't think, is horizontal cutting planes. So we do them at even distances, and we can then determine specific points where the generator and the horizontal cuts intersect the cut surface in end elevation. There it is. We can bring those points across into our elevation from our end view, so we can plot those curves. by labeling and being accurate with our labeling and drafting them with the coordinating points. Then we can bring those exact points straight down into plan view, so we can keep the same labeling, the same generator, and the same cut and plane brought straight down into our plan view. So then after that, it moves on to I'd leave the development of the square base prism second. I do the truncated cone first. So to do that, I discuss what they might have been familiar with, the generators, all of the generators that we plotted, label them exactly. Using our true length view we have here opposite our end elevation, we can take our heights from the apex down towards our points with a compass and do exactly that on the same development to find the cut surface and the shape of the developed out cone, or the net of the cone. It's not that hard then, again, for the square base prism. After being cut, we know the measurements of our square base prism. We can find the green area fairly easily, then find the lines of cutting, the cutting intersection lines. We can bring those down from our plan view straight down. If our labeling is correct, one of the problems that I had myself out on placement with development is students getting mixed up and frustrated when labeling doesn't go according to plan. So if that goes according to plan, it should be handy enough to take our points straight from our plan straight down to the subjected line that they're on, and they can plot the intersection lines of the square base firm. And that's the question pretty much done then.